Gauss elimination method. Gauss elimination method is a direct method to solve the system of linear algebraic equations. Now the system of linear algebraic equations, it means it's a set or a collection of linear equations. So a set or a collection of linear equations is called the system of linear algebraic equations. This is an example for a system of linear equations. Here we have three linear equations. It forms a system of equations, linear algebraic equations. Now we are going to solve this system using Gauss elimination method, which is a direct method for solving the system of linear equations. Okay, now the first step in Gauss elimination method is to convert this system of linear equations into a matrix form, into an equivalent matrix form. So the equivalent matrix representation of a linear set of equations is Ax equal to B, where A is the coefficient matrix, X is the matrix of unknowns, and B is the constant matrix. Now, a coefficient matrix means a matrix with the coefficient values of the system of linear equations. So here the coefficient values is the first column of the matrix represents the coefficients of x in all the three equations. Likewise, the second and third columns represent the coefficients of y and z respectively. Now look at the coefficient matrix of this system. The first column is we have values 1, 2, 3. 1, 2, 3. In the second column we will be getting 2, 3, minus 1. 2, 3, minus 1. And in the third column 1, 3 and 2. 1, 3 and 2. Include the signs while writing the coefficients. So the first this matrix represents A, the coefficient matrix. Now the second matrix is X, which represents the unknowns in the system of equations. It is a column vector, so it contains a single column with all the unknowns in order. So the first unknown is X, then Y and Z. So X, Y, Z. Now the third one, that is equal to B. B represents a constant matrix, that is the constants in the equations. That is also a column vector, so just write the constants in a single column. 3, 10, 13. So this is how we represent the given set of equations in matrix form. The matrix form is Ax equal to B, where A is the coefficient matrix, X the matrix of unknowns, and B the constant matrix. Now after representing the system of equations in matrix form, we have to solve it to find the values for x, y and z. For that, the first step is we have to form an augmented matrix AB, where A is the coefficient matrix and B is the unknowns. The augmented matrix is found by combining these two matrices. Okay, so the augmented matrix AB will be a combination of matrix A and matrix B. So this is how it looks. Okay, the first the matrices A and B are combined together and represented in a single matrix, and that matrix is called the augmented matrix. So we'll start by the augmented matrix AB, and now our aim is to convert this matrix into upper triangular matrix. That is, we have to convert this matrix into upper triangular matrix. An upper triangular matrix is a matrix where the elements below the diagonal are 0. The elements below the diagonal are 0. In this matrix, the diagonal elements are 1, 3 and 2. The elements below the diagonal matrix will be 2, 3 and minus 1. These elements are to be converted to 0 using row operations or row equations. So by writing row equations, we will convert the elements below the diagonal to 0. Okay. For that, we have to write the row operations. Now let's consider the first diagonal element. Our first diagonal element is 1. So first we have to convert all the elements below 1 to 0. So we have two elements below 1, that is one in the second row and another in the third row. We have to convert these two elements to 0. So whatever equation we write to convert these two elements to 0, we have to apply it to the entire row. So let's see the first first equation to convert the first element. That is, we are going to convert 2 to 0 by writing a row operation. So whatever we write, we have to apply it on the second row completely. So let's write the first equation. So we are going to convert row 2, right? So first write row 2, then we have row 2 becomes what? We have to convert this 2 to 0. So to convert 2 to 0, we just need a minus 2. We just have to add a minus 2 to 2. It will be converted to 0. So that should be done with the help of the corresponding diagonal element. So 2 comes under the diagonal element 1. So whatever equation we write, we have to write it with respect to the diagonal element. So we are going to convert 2 with respect to the diagonal element 1, which is in row 1. So the equation should contain variables row 2 and row 1. So now to convert 2 to 0, we need a minus 2 to add, right? But we have 1 in the diagonal element position. We have 1. To convert 1 to minus 2, just multiply 1 by minus 2. That means the row 1 should be multiplied by minus 2 to convert this 1 to minus 2. That is what is done here. Row 1 will be multiplied by minus 2 and then add it to row 2. That means row 2 plus minus 2 into row 1 will make this 2 0. That is the equation we are going to use for each element in the second row. Okay, so row 2 will be converted by adding row 1. Before adding row 1, we have to multiply row 1 with minus 2 and then add it to row 2. It will convert 2 to 0. So that is the equation we are going to apply for row 2. Similarly, we need an equation to convert this 3 to 0. This also should be done with respect to the diagonal element 1 because it comes under this 1. That's why we are converting it to 0. So to convert 3 to 0, we need a minus 3. So it can be obtained by multiplying 1 into minus 3. So the equation for the third row will become R3 becomes R3 minus 3 into R1. Okay, but now by applying these two equations on this matrix, this augmented matrix AB, we will get the matrix, this one. The first row remains the same since we haven't applied anything to that. We were aiming to change the elements below 1 to 0. For that, we wrote these two equations, and by applying these two equations on the rows completely, we get the new matrix like this. Now this has to be done again since we the first diagonal element 1, the elements below the first element we have converted. Next diagonal element is minus 1. This we have one element below minus 1, so this should also be converted to 0. So next equation we have to write is to convert this minus 7 to 0. So to convert minus 7 to 0, we just need a plus 7. And we have to get that plus 7 with respect to the diagonal element. Here the diagonal element is minus 1. So minus 1 should be converted to 7. To convert minus 1 to 7, we have to multiply it by minus 7 itself. So the second row should be multiplied by minus 7 and then add it with the third row. So R3 becomes R3 plus minus 7 into R2. This is the equation. So applying this equation to the third row, we will be able to convert this minus 7 to 0 also. So after applying, we will get the matrix like this. The values will be like this. Now the next diagonal element is minus 8. Since we don't have any elements below this minus 8, we can stop applying row operations here. Okay. Now look at the matrix. The diagonal elements are 1, minus 1 and minus 8. All the elements below the diagonal element are now 0. That means we have converted the matrix augmented matrix AB to upper triangular matrix. The next step is to represent this matrix in the form of equation. We started by converting the equations, converting the given equations to matrix, and at the end we will be, after converting the matrix to upper triangular matrix, we will be representing that as equations. Okay, so the first equation will be, here we know that these three columns represent the coefficients of the unknowns, right? So the first value will be the coefficient of the first unknown. The first unknown is x. So the first row will be converted as, this is the coefficient of x, right? So 1 into x plus 2 into y plus 1 into z is equal to, the last column represents the matrix B. So equal to 3. That is what is written here. X plus 2y plus z equal to 3. Now the second row becomes a second equation. Here in the second row, the coefficient of x is 0. That means we don't have x in the second equation. So the second equation starts from y. Coefficient of y is minus 1. So minus 1 into y plus 1 into z equal to 4. And we get minus y plus z equal to 4. The last row, look at the last row. Here coefficient of x and y are 0. So we start the equation with z, and the coefficient of z is minus 8. So we get minus 8 z is equal to minus 24. So these are the equations we get after converting the upper triangular matrix to equations, right? Now look at the equation. We have to solve these equations to get the values for unknowns, and it is done by back substitution method. The back substitution method means we will be going in the from the last equation. We will first solve the last equation, then using that we will solve the second one, and using that we will solve the first one. That is back substitution method. So we start with the last equation. Here we have minus 8 z is equal to minus 24. From that we get z. Z is equal to minus 24 by minus 8, which is 3. So by back substitution method we will get the value of z first. So we got z first. Now applying the value of z in the second equation, we will get the value for y. So minus y plus value of z is 3. So minus y plus 3 is equal to 4, which we get y equal to minus 1. Okay. Now applying these two in the first equation, we will get the value for x. So x plus 2 into minus 1 plus 3 is equal to 3. Right. So by simplifying this, we will get x minus 2 plus 3. Minus 2 plus 3 will become 1. And x plus 1, right. X minus 2 plus 3 equal to 3. That is x plus 1 equal to 3, which is 3 minus 1, that is 2. So we will get the value for x as 2. So now we have found all the values of the unknowns, and the answer will be x equal to 2, y equal to minus 1, and z equal to 3. Okay. So this is the Gauss elimination method. Next direct method is Gauss Jordan method. This is also used to solve the system of linear equations. So the difference in Gauss Jordan method is that it's a modification of Gauss elimination method, where instead of converting the augmented matrix to upper triangular matrix, we convert it into a diagonal matrix or a unit matrix. That means we have to convert the augmented matrix to a matrix where the elements above and below the diagonal elements are converted to 0. That is the diagonal matrix. Okay, the elements above and below the diagonal elements are converted to 0. Now we will take the same question which we have used to find, which we have used in Gauss elimination method. So in that method, the augmented matrix was, this was augmented matrix. So here the diagonal elements are 1, 3 and 2. So here we have to convert all the elements above the diagonal element and below the diagonal elements as 0. Before in Gauss elimination, we just converted the elements below the diagonal elements to 0, right? Here we have to convert the elements above and below the diagonal element to 0. So we start with the first step which we have done in Gauss elimination. First we will take the first diagonal element and convert the elements above and below it to 0. Since the first diagonal element doesn't have any element above it, we have to convert the elements below the diagonal element 1 to 0, which we have already done in Gauss elimination by the equations, by the row equations. R2 becomes R2 minus 2R1 and R3 becomes R3 minus 3R1. So by applying this we got the matrix like this. Now here the next diagonal element is minus 1. Before in Gauss elimination we just converted the element below the diagonal element to 0. So minus 7 was converted to 0 in the Gauss elimination method. Using the equation R3 becomes R3 minus 7R2. Now we have to convert the element above minus 1 also to 0. In Gauss Jordan we have to convert elements above diagonal element also to 0, right? So we need an equation to convert this 2 to 0. Since this 2 comes in row 1, we are going to write a row equation for row 1. So row 1 becomes, we have to convert this 2 to 0. That means we need a minus 2. We have to convert this diagonal element minus 1 to minus 2. To convert it to minus 2, we just need to multiply it by 2. So row 2 will be multiplied by 2 and added with row 1. So row 1 becomes row 1 plus 2 into row 2. This is the equation we are going to apply for row 1. So applying these two, we will get the matrix like this. Okay. Now we got, now look at the elements. The first two diagonal elements were 1 and minus 1. We have converted the elements above and below this 1 and minus 1 to 0. Now this third diagonal element is minus 8. We have to convert the elements above and below minus 8 to 0. But since we don't have any elements below minus 8, so we just have to convert the elements above minus 8 to 0. That is, we have to convert the elements 3 and 1 to 0. So we have to write the equations for row 1 and row 2 using row 3 and convert it to 0. Now look at the value in row 3. We have minus 8 and minus 24. Since 24 is a multiple of 8, we can reduce the elements in row 3 so that it will be easy for us to write the row operations or the row equations. So I just use an equation, an additional equation to convert row 3 to smaller values. So since 8 can be used to convert this 24 is since 24 is divisible by 8 completely, I just divided the entire row, that the third row, by 8. So this is how we write the equation. R3 becomes R3 into 1 by 8, which means we are dividing R3 by 8. So by doing that, I'll get the third row like this. That is, I get the values as minus 1 and minus 3 instead of minus 8 and minus 24. Now it will be easy for me to write the row operations for row 1 and row 2. So this step is not compulsory. If you want, you can just reduce the values by dividing with a common factor. Okay. Now I have done it and I have got the values like this. Now using these, now my diagonal element is minus 1 here. In the third row, the diagonal element is minus 1. Now I have to convert 3 and 1, which is above this minus 1, to 0. Now the equations we get is R1 becomes R1. In R1 we have 3. So I have to convert 3 to 0. That means using minus 1. This is minus 1 is the element which I have to use to convert 3 to 0. So multiplying this minus 1 by 3 and adding, it will be converted to 0. So R1 becomes R1 plus 3 into R3. Now the second row is the element above diagonal element is 1. That means just adding these two values, this will be converted to 0. That means row 2 will become row 2 plus row 3, and using this equation I can convert this value to 0. So these are the row operations which I had to apply to convert the elements above this minus 1 to 0. Now after applying it, the matrix will become like this. Now look at the matrix. All the elements above and below the diagonal element are 0. Now converting this into equations, we'll get from the first row we'll get the first equation. Now look at the first row. Here only we have a non-zero value only for the only in the first row. That means we have a coefficient for x, but we don't have coefficients for y and z. That means the first row, from the first row we'll get the equation as x equal to 2, and this from the second row we get minus 1 y equal to 1. From the third row, minus z equal to minus 3. Now converting these two, we get, equating these two, we get y equal to minus 1 and z equal to 3. And that's the solution for the given question.